Welcome to Dev308. Earn your DevOps Black Belt, deployment scenarios with AWS CloudFormation. My name is Chuck Meyer. I am a senior developer advocate for AWS CloudFormation. With me is
Luis. My name is Luis Colon, and I'm also a senior developer advocate with AWS CloudFormation. I've been with the group for a couple of years, and I'm very excited to be able to talk to you guys today.
Great. So we're very glad to have you here. We're going to be talking about continuous integration and continuous delivery strategies for infrastructure, right? So
take it away.
Thanks a lot. So in order to do that, what we tend to do with presentations like this, particularly like 300-level presentation, is we're going to start with some very brief kind of refreshers, both on CloudFormation and sort of CI/CD terminology, just to kind of level set everyone. I'll try not to spend too much time on it, but it's just kind of a good way to sort of make sure we're all on the same page, we're all kind of talking the same language. Once we have that together, we're going to go ahead and start building an infrastructure pipeline. So we're going to start treating our infrastructure as code, doing all the things that we would expect you should be able to do with code. And we're going to be talking about the tools that we're going to be integrating into those pipelines to succeed. Once we have that sort of put together, we're going to dig in a little bit further on how to integrate in testing and validation to that pipeline. Then we're going to hand off to Luis, who's going to talk a little bit more about full stack deployment scenarios, right? So where you're deploying your infrastructure alongside your application in sort of a continuous manner. And we're going to finish up with serverless deployments, which have a few additional nuances. So there's sort of an inheritance here. As we learn stuff, it'll all apply. It just sort of gets more nuanced as we go along. Okay. So anything that's not a 400-level session, I like to put this slide in. First of all, just hands up, who in the room? Who are active CloudFormation users already? Okay, cool. And who are here because they're interested in sort of getting into infrastructure as code? Okay, a few folks. Okay, so I'm just going to spend a little bit of time on this slide. This is my one-slide version of what is CloudFormation. And so just to kind of go through it quickly, CloudFormation is AWS's infrastructure as code service. So it's a service that sits up in your account, and you describe the infrastructure that you would like to deploy in a text file that could be written in YAML or JSON. You might write it yourself. It might be generated by a tool. But however you sort of create that file, once you have it, you put it into an S3 bucket in your account, and you tell CloudFormation where that file is. The CloudFormation service then retrieves that file, processes it, determines the appropriate order to start deploying infrastructure for you, and then has a whole workflow on the backside to provision things in the correct order, make sure that they stabilize appropriately, and then let you know at the end once everything's available and ready to use. As that infrastructure sort of continues through its life cycle, you have opportunities to modify that template and then perform updates, and CloudFormation will try to figure out what has changed and then make the appropriate API calls on the backside to make your infrastructure match that new version of the template. Okay, so that's sort of the basic version of CloudFormation. Lots of folks, sounds like they're already using it, but that kind of helps everyone understand where we are with it. Okay, so moving on from that, talking about CI/CD. Who here has some sort of continuous integration, continuous delivery pipeline going already? Okay, for your code and stuff. Awesome. Again, we're just going to kind of make sure that we're all speaking the same language. These are some basic concepts around continuous integration, continuous delivery, and continuous deployment. So, we assume you know a little bit about this already, but just to make sure we're all speaking the same language, continuous integration, taking source code, going ahead and compiling it down, generating artifacts that are ready to go out into your environments. Continuous delivery or continuous deployment is taking those artifacts and then orchestrating, pushing them up into environments in sort of an organized manner. Biggest difference between continuous delivery and continuous deployment is whether or not you gate on production. Your appetite for just going for it and getting things all the way into production because of your confidence in your level of testing that you're doing up into that point, right? So the most important thing about this slide, though, is the 4 categories at the top: the source, build, test, and promote. And that's kind of the stuff that we're going to carry forward as we start taking these concepts and sort of mapping them onto infrastructure, right? So we're going to be talking about versioning, building your artifacts, and we're going to be talking about that promotion process as well, right? So we say very often, treat your infrastructure as code. But now your infrastructure is code. This is something that you need to accept, embrace, and treat it that way. And even those of us that have been doing this for a while haven't necessarily done that. There haven't really been the tools to do the types of testing, the types of validation that you have that gives you that level of confidence. So I see we've got a lot of CloudFormation users who's opened up a file and then just thrown some JSON or YAML in it to build their template. Okay? And then who's taken that template and just uploaded it to the console and seen what happens. And then who's come back an hour later to see if it's finished rolling back appropriately. Right? Okay. So that's what we want to avoid, right? We wouldn't do that with our application code. We wouldn't just throw it into an environment and hope for the best. I don't know, maybe some of us would, right? I don't know, I was in college once. But we should be treating it like code. We should be doing all the same things. We should be doing the version control. We should be doing integration testing, right? That promotion through environments should be orchestrated. It should be done in an organized and consistent manner. And that's what we're going to do today. Okay, so the first of those categories is source, right? Version control everything. Your CloudFormation templates should be in some sort of source control. The parameters that you're passing into your CloudFormation templates, you can put those in a JSON document. We'll consume that. That should be in source control, right? Hopefully, any configuration management or shell scripts or any sort of helpers that you need, you were already doing source control with, but that all needs to live together. This is all pieces of your infrastructure as code. So that should be going into something like a Git repository or a Bitbucket if that's something you use. At the very least, if you're throwing it all in an S3 bucket, please just turn on versioning, right? But give you that version control so that you can see how these pieces of code are changing over time and who's changing them. That's kind of the root of everything, and just like it would be for your application code. So the next we talk about the build phase. Well, if you're just doing straight up CloudFormation, you've already got your JSON or your YAML document. It's not like you're compiling it. So when I talk about build for infrastructure as code right now, I'm talking more about static code analysis. And the good news is that this is an area where tooling has really matured in the last couple of years. There's a lot of really interesting tooling out there in the community for doing these types of things. The two tools that I tend to focus on in this space, one selfishly and one less selfishly, are CFN-lint and CFN-NAG. Now, the one thing that I want to point out about CFN-lint, it's a great tool. It's a syntactic validator for CloudFormation, right? So it actually goes beyond what doing a validate template in the API does. It doesn't just check to see if it's good JSON or YAML. It's going to check your files against the resource specification. It's going to let you know that you have the appropriate properties, and to the extent that it can, whether or not the values kind of match up to what it's expecting, whether it be a string or an integer or what have you. There are two different tools called CFN-lint. One was written by a gentleman named Marty Sweet. He wrote his in Node, and it's a great tool. Ours is called CFN-Python-lint, and it was written by some folks, some AWS field folks, and it's pip installable, so because it was written in Python. The primary difference, other than the languages that they're written in, is sort of how they handle conditionals. I tend to like the way the Python version, CFN-Python-lint, handles conditionals a little bit better. It tends to go and sort of navigate all of the paths of conditionals to make sure that sort of everything's valid across the board. Traditionally, the other CFN-lint would ask for parameter values and then sort of follow the happy path. Obviously, as with any tooling, we're both evolving and kind of hitting each other's space. But the one I'm going to be focused on is CFN-Python-lint today. Now, in opposition to CFN-lint, which is looking at sort of syntactical correctness, CFN-NAG, which is a tool that was written by our partners at Stelligent, is looking more for best practices. So CFN-NAG is checking to see whether your IAM policies have asterisks in them, right? Whether your security group ingress rules are using 0.0.0/0? Do you have encryption turned on? Things like that. Who in the room is using CFN-NAG already? Okay, a few folks. Who's using one of the CFN-Lint flavors? Okay, cool, cool. If you asked me which one should I put in my pipeline, every time I would say both right now, because I think both are important. I like to say that CFN-Lint is, can I deploy this template? And CFN-NAG is, should I deploy this template? And I think those are both important questions to be able to answer, right? And let's see, the interesting kind of other piece of the puzzle here is, the ability to put this, not just kind of run them locally, but the ability to put these directly into your pipeline, right? And be able to sort of have this as sort of an analysis step within your pipeline itself. So this is just a quick look at CFN-Lint. This is kind of showing a appropriately named bad route table file. Running it through the linter via the command line, you can see that it's found an error in my file. It's telling me the specific error number, and it's also giving me sort of a location. We're going to drill into this particular error a little bit in a demo, so I'm not going to dwell on it too much right now. We're going to move on to integration testing, right? So there are lots of things that you can catch with tools like CFN-NAG and CFN-Lint about the validity of your template. But then there are things that you just don't know until you actually go and deploy into a live environment. And so the first tool that I found that I've really liked in this space was actually written by our friends over at the Quick Start team. Anyone here who's deployed a Quick Start? Okay, cool, we've got a few folks. So the Quick Start team, what they do is they work with partners to sort of define complex architectures that solve specific problems using partner solutions. And they build very complex CloudFormation templates. They actually have one that's pretty cool that deploys a validation pipeline for CloudFormation templates. So a little plug there. But because they're building these complex templates and then vending them out to all of you who are going to deploy them in every region, right, in every kind of permutation, they needed to make sure that they had a consistency and that it was going to work for you. So they wrote this tool called TaskCat. And TaskCat is a tool that you provide with a CloudFormation template and a small YAML file that has sort of a list of regions that you want to deploy into and information about parameter values. And then it'll go and deploy that template across those regions with those values, and it'll generate a report at the end and tell you if it was successful, where it failed, and what messages it got back from those particular stacks. And this is a great tool for finding out things like, oops, it looks like that service that I really wanted to use is not actually available in this particular region. I need to be aware of that and code around that, right? Or, oops, I want to deploy this template and it turns out someone else has already deployed it and there's already an export with that name, right? These are things that you can't find just from the code. You have to actually go and deploy them somewhere. And so that's kind of where TaskCat comes into the pipeline. This is a run of TaskCat. I know it's a little bit small here, but basically what you're seeing here is I've taken a VPC template and I've told TaskCat that I want to test that in US East 2, my favorite region because I live in Columbus. And TaskCat is giving me the results of that. It's saying I was successfully able to deploy it. Everything looks good. Let's go forward. Okay. So now we've got a pretty solid level of confidence that not only is this template valid, but it actually deploys in the regions that I wanted to deploy, right? So now I can finally move beyond testing, and I can start promoting this template up through my environments. Well, we want to make sure that we're doing that in a consistent and unified way, right? And so this is the exact same thing we would do with our application code. We want to promote. We want to make sure that we are starting out in some sort of integration or acceptance environment, moving through staging up through production. But we have to make some choices here. You know, how is that going to happen? CloudFormation, one of the things it does very well is handle in-place updates. But there are some places where that in-place update might require us to replace a resource. You know, so what does that mean for us as we move into production? Are we comfortable with that? Are we okay with letting CloudFormation do that update? Do we need to deploy a separate stack, validate that, and then move traffic over using something like, you know, DNS entries or something with, you know, some other sort of mechanism? These are kind of the choices that we have to make. And this should be decided by our tooling. This should be done using an orchestration tool like CodePipeline or Jenkins or any sort of other orchestration tool that you might have lying around. That's the important point to do it. But the other place to sort of think about here is what's your strategy around accounts and regions? Do you have a multi-account strategy? Do you have a multi-region strategy? Is it replicated? Do you need to make sure that they are consistent on both sides? Is it a failover? Are you routing traffic because of latency, and you just need to make sure that you've got the right things sort of in each environment? And does your tooling support that appropriately? There's some interesting things in this space as well. CodePipeline recently injected the ability to deploy to multiple regions. That's pretty good for failover scenarios, right? You can make sure that you've got a consistent deployment to east and west, or however you're sort of splitting things up using CodePipeline itself. CloudFormation has a feature called stack sets that allows you to deploy out to multiple accounts in multiple regions. Can you leverage that to make sure that you've got sort of consistent deployments across all of the things that need to be identical? Does your orchestration tool itself have what it needs to be able to do that? Could you simply do it with multiple sets of credentials in your Jenkins server or something like that, or assuming roles? So these are the sort of things that you need to think about. It's the stuff that I can't say this is the best way to do it. It's going to be sort of specific to the way you do your deployments. But the important thing here is that it's done with consistent tooling. Okay, so this is putting it all together, right? This particular version is taking advantage of our sort of SaaS CodeStar products. So we're sort of consuming all of it here. We've got a developer who's writing up their CloudFormation templates or generating some Python code and using Troposphere to build that JSON file. They're pushing that into code commit, which is our S3-backed Git repository. That is triggering a code pipeline. Code pipeline is then using code build to execute CFN-lit and CFN-nag against those templates to make sure that they're actually okay, that everything's good there. If that works out all right, we are going to trigger a Lambda function that's going to execute TaskCat. Lambda's going to go run that TaskCat. TaskCat has the ability to generate a report. We can then look at that report, or we can send information from that report back up to say that, hey, we were successful. Once we're successful, we can start promoting up through environments. So we're going to use CodePipeline's native integration with CloudFormation to start deploying out into environments. And then we're going to have to make that decision whether or not we want to stop before we hit production and put some sort of manual gate in there so that someone can go look at all of the stuff and make sure that we're happy with it. So that's sort of the CodeStar way of doing things. But that's not the only way to do it. It doesn't really change much if you're using your existing tooling. You can do this just as easily using Git, GitHub, Travis CI, your build tools of choice, good old Jenkins for the orchestration layer. The only thing that changes really is sort of how these things are coupled together and where permissions live to be able to do what you need to do, right, for things like provisioning out into your environments. But the process doesn't change. It's simply just the tooling that changes. Okay. So going from there, I kind of wanted to give a quick little demo here. I wanted to show off mostly the linter here. But we're going to do this. Let me see. Oh, sorry about that. Let me quickly get this back up and running here.
While Chuck is typing, I'll add, thank you. While Chuck is typing, I'll add, when you see some of these pipelines, pipelines like applications are just starting points. I remember setting up pipelines 6 or 7 years ago, and the first pipelines only had like unit testing and integration testing, end-to-end testing. In analytics pipelines, you may have other components. In some other code pipelines, you may have tests for code coverage. Your application may also require things like warming up the cache and everything. So not only do you, as your application and your processes become mature, you keep adding steps to those pipelines. So consider this kind of like a good basic starting point and evolve from there.
It's an excellent point. So where we're going to start for this particular demo is in a GitHub repo. This is my aptly named CFN-lint demo repo. It contains some CloudFormation templates in a template directory. And one of the things that I have done here, as you can see, I've actually got a build badge for my templates. So you can see that as far as we're concerned, we feel like these templates are in pretty good shape. So I've got my VPC template, I've got a load balancer, and a security group here. Everything looks pretty good to me. And I do notice that I've got a pull request over here. So I can go take a look at that. Added new route table association should be fine. Let's take a look at that one.
Famous last words.
Right. So you can see here, I'm using GitHub's sort of built-in integration with Travis CI, and I've actually run some tests against my templates here in this pull request, and it looks like it's not going so well. So we're going to click through here and look at the details of that. So here we have my pull request. I can go in and look, and I've run the linter, and sure enough, we've found some errors here. It's our good friend, the bad route table association, and it looks like it's having some problems. So let's go ahead and take a look at that template here. I've actually got this in Visual Studio Code. Now the interesting thing here is, let's see here. Oh, that's not doing what I wanted it to do. Visual Studio Code, typically, but because it's a demo day, it's not working right now. But Visual Studio Code has a plugin for the linter that looks like it's not installed right now. So let's see. Let's reload. There we go. Has a plugin for the linter. So I can actually bring up that same template here, and sure enough, I've got my little squiggly lines around my errors and my warnings, right? And there's that error that I'm seeing. So let's take a look at that again. So interesting fact, you can only have one route table associated with a subnet and a VPC. If you try to associate multiple route tables with a subnet, not only does it cause some issues, but there's actually deletion ramifications there that can get very, very messy. So this is actually kind of a bad thing to have happen. So why is this happening here? Well, if I look up here, I've got this little green line up here, and it turns out I've got this parameter, this private subnet parameter that's not being used. And looking down here, oh, sure enough, I've got my public subnet here in my private route table association. So let's go ahead and fix that. Okay, all of my squiggles have gone away. So this seems to be in pretty good shape. So we're going to go here. We'll go ahead and add that file back in. And because I am an awesome dev, we're going to put a really good commit message
Oh, he's
here.
okay. Awesome might be kind of stretching it, but
Yeah, right.
he has fans and he gets Christmas cards and everything. He's pretty good.
Yeah, for those of you, so for some folks, infrastructure as code is actually your first journey into using some of these tools. And there's kind of, I in the past have been as guilty of anyone of kind of treat this as a little laissez-faire. I don't really treat the tool as well as maybe I do when I'm writing my application code. But this is important, right? Like if something did go wrong with that route table, this is how we're going to figure out what was going on. So we need to treat these just as real as we do our commits for our application code. Let's go ahead and push that. Cool. And then we're going to jump back over here. Let's see. I'm going to refresh. Let me make sure that we've got the right version of our file in here now. So we've got our private subnet here. I can see it in my pull request. We can jump over to Travis again. Let's see here.
Since most of you are CloudFormation users, how many of you consider yourselves to be expert Git users? Okay.
Okay. So you can see fix that thing is my current commit here. Travis is now going ahead and it's doing its installs. Getting the linter in there.
Can you reload that?
Let's see, and at the end of the day, what we should see here is a successful build. Why does it always go so slow when you're on stage? Oh, I didn't mean you.
You see that? You see what happened?
There we go. Exit with 0. Looks like we're clean here.
I was stepping on the cable. That's what I was doing.
All checks have passed, and we're all set to squash and merge. I did my code review, right? You saw me go in there and look at it. So let's go ahead and confirm that. And there we go. So our route table association is now in our repository.
So that build bash now should show that it passed, right?
Should we show that again?
Yeah. Because, you know, we're nerds and everything, right?
Yep. So we're passing up here. Now, why did the build badge in the repository still say passing when all of that badness was happening?
Maybe you didn't want to hurt your feelings.
I was working in an alpha branch, right? So just like I would with my regular code, I wasn't pushing up to master.
That's right.
You're going to work in a separate branch for whatever feature you're working on, and you're going to merge it in. OK. So I think that takes us through my side of the presentation. Luis, if you want to come on over, and I will get you going over here.
All right.
Thanks.
Thank you, Chuck. If it sounds like I've been smoking since I gave birth, it's because I lost my voice, but don't feel bad about it. And if you find it funny, it doesn't really hurt my feelings at all. So let's talk about full stack deployment. Full stack is now a term that gets thrown around a lot. And not only have I heard it about deployments, but also about full stack developers. Any of you consider yourselves full stack developers? Some of you do. What I've seen with customers is that these full stack developers are typically in smaller companies where perhaps they don't have a dedicated operations team and a dedicated development team, et cetera. And they have to pretty much not only understand their product, the application, the servers they're installing on, doing maintenance, et cetera. And some people consider that a pretty tough job. I think it's super powerful. And I think that one of the biggest benefits that full stack developers would probably attest to is that since they know everything, when the problem happens, they can literally look up whether something is wrong on a commit from Git or something's wrong in the configuration of the server. So it's not a bad thing to start thinking full stack if you haven't been a full stack developer before. In this context, however, we're going to talk about full stack deployment that includes your application code, all the app servers and things that you have to configure, and all the network compute and storage. So it represents the entire pie. This is very powerful. It used to be that you could not, sometimes that in the initial pipelines that first became popular maybe 6 or 7 years ago, you could only do the pipeline on the front, but still the network and the servers and the data centers and the racks still have to be taken care of manually. Now, really, we have the ability to do all these things in an automated manner. And why be so hung up about doing it in an automated manner? Automated means you can do a lot of changes, you can do them quickly, and you can do them with proper testing. Because also, if it weren't automated, you can do a lot of changes and break a lot of things too. But that's a quick way to lose friends. We're going to show you some examples as to how this full stack deployment does apply to any application architecture that you may encounter. This first example is a traditional, feels like a LAMP application, assuming you're using Linux for this. And the infrastructure will include setting up your VPC availability zones and other components, load balancers. On top of that, you install your app servers. In this case, it will be like a Django CMS. You can use your install and set up your database and configure your database, MySQL, Postgres, others. Nginx as your web server. And then Chef also to do configuration management and other activities. And then on top of that, then your code and the necessary things, assets that your code requires. This also applies to containers. And in the container world, what you probably end up doing is setting up Docker images, and then every time you do a deployment, you go through the testing of your code, generate the new images, deploy them, And in many cases, because of the benefits of containers in general, you can make these pipelines a lot faster. And that should be one of the things, when you think about pipelines, continuously monitor those pipelines, make them faster, because over time, chances are that as your application changes, it will add features, it will add tests, so there will be that tendency for those pipelines to become slower. Serverless, absolutely. The infrastructure and the services part for serverless becomes a lot smaller, especially if you're using something like SAM, Lambda, or the serverless application architecture, serverless application model, or the serverless framework, where there's a lot of the components that get generated for you, but what doesn't usually get generated is test events and the testing that you have to do. So there's plenty of strategies when we deal with full stack development. One of the key ones that we encounter and we advise people to do is to group resources by lifecycle. This has two primary benefits. Number one, imagine your entire application and your application including VPC, network rules, setting up roles, setting up users. Chances are parameters or configuration for those components are not going to change once an hour or once a day or once a week. So it makes sense in some situations, especially in compute situations, to have those as a separate pipeline. And the other pipeline becomes the application. Now that pipeline you could potentially release code once an hour, many times a day, once a week, et cetera. And those pipelines don't affect each other. When a problem happens, you're essentially reducing the potential blast radius, as we call it, so that if you always include everything in your pipeline, then a lot of things are going to change at the same time. Now, there are cases that including things in the pipeline make a lot of sense. The idea is that if you have everything well automated with good monitoring and good testing, you still want to make sure that that step that only deployed the application only could have affected the application. So here, to kind of like be more specific about it, when we talk about lifecycle, it's about separating longer-lived resources from resources that change a lot, and isolate resources that are stateful, resources like databases or queues. Let's get into some examples. In EC2, it makes sense to, in this particular example, to use two pipelines. The first pipeline might be my infrastructure YAML, and maybe that one I only change monthly. I set up the VPC, autoscaling group, and perhaps as months go on, I have to add subnets to have places for other applications to run. The daily one, I may have to change the load balancer, my application gets tested, and maybe I bake an Amazon machine image or AMI, and that's the only thing that changes. Everything else does not change. So you can see by having these two individual steps, the steps are smaller, they're faster, they're easier to test, and they have a smaller blast radius. Now, this is how that particular EC2 example looks like. It should look really familiar because we just talked about this before, where you have code commit, pipeline, using tools like CFNlint and NAG, TaskCat. And TaskCat, it's powerful enough, and the people that wrote it use it not only for relatively simple templates, but they also use it for fairly complex nested stacks. If you ever wanted to learn more about nested stacks and wanted to look at a huge example that works, take a look at some of the nested stacks that the Quick Starts team puts together. They're quite impressive. And then you use, of course, CloudFormation to update your application scaling group and set up things like blue-green deployments, canary deployments, et cetera. Let me get a sense of, for some of those that are using pipelines today, are you deploying blue-green today? Some of you are. Excellent. Now, canaries apply when you have hundreds of servers and everything. How many of you are deploying with canary deployments? Excellent. Those are the kind of like process automation maturity models that you should strive to get to. Now, this is an example of the application part. of the pipeline. This is your typical CI/CD pipeline that would have things like unit tests, test coverage. Maybe if you have tools to actually check for security and vulnerabilities, you would have these as well. In this pipeline, after we finish our integration test and we believe that the application is ready to be baked, then we're baking the machine image, and then we start deploying that on staging. Now, trick question, see if you can figure out the trick. Is it a good idea to test in production? Yes. Awesome answer. Because the trick, when that comment fails, if you're only testing in production, no good. But the reality is that the proper amount of testing, once you land in your environment, including production, you should be doing something that some people call smoke testing, just to make sure that you pass traffic, do the testing before you pass traffic to the freshly minted servers. And in the same way that you should do it in production, you should do it every time your application lands in any one of those environments.
So one sort of interesting thing I wanted to point out about this as well is, not only are these two separate pipelines, but there's a decision to be made about what's going to drive those pipelines. Are these two separate repositories? There are some cases where it might make sense for you to source your infrastructure code from a different place than you do your application code, and that's sort of what this is representing. Mm-hmm. So.
Versus, I believe in the next case, there actually can be sourced from the same repository. Mm-hmm. So.
Can you define what you mean by production?
The question is, can I define what I mean by production? I typically define production where I'm having real customers creating real transactions and processing real money. Now, that seems kind of like a very narrow or simplistic definition, because in many cases, you will have large companies that will provide the new version to be tested by other people. And if there's people using your application and you need to care for their personally identifiable information, you might call the environment QA or preview, but you need to treat it as production as well.
IDLC and SDLC are two different things, right? The definition of production from an IDLC standpoint is very different from the definition of production in the SDLC world.
Okay, all right. And that's fair, and I think there's a lot of people that would agree with that statement. All right, so we looked at basic compute with EC2. Now, if you're leveraging containers in Docker, you may set up a container pipeline. This may be sourced from the same repository. And this is the kind of thing that, especially in medium and large size companies that have been around for a while, you're always going to have a mix of traditional compute, Docker applications, serverless applications. The fact that you have that kind of mix and some of the applications are more legacy than others should not stop you from having multiple pipelines, sometimes for those different applications, and sometimes pipelines that may combine some of those. Here, in the container pipeline, we'll have our environmentals setting up our load balancers, our security groups, et cetera, in the cluster. And then the parts that probably change a lot more often are your service, your task definitions that create Docker containers that need to get registered and deploy. So still the pipeline looks rather similar. Things are going to be checked in for your versioning system. It's going to go and build your code pipelines. You're going to then, once your tests run, build your Docker images. Then you'll have a whole bunch of templates and then deploy those things with CloudFormation again. The idea here is to be able to repeatedly deploy the exact same thing. We don't want any snowflakes in our clusters and in our environment. Go through different environments so we have opportunities to test, and test once the code lands in those environments, including production. Now, this is just one example using very Amazon-orientated tools, but containers on Docker and Kubernetes are such a popular area right now that you will have many other utilities from many other companies, some of them APM partners. I want to highlight this one by Stelligent, which Chuck talked about a little bit before. They are the same ones that write CFN NAG. They wrote this tool called Mule. It's open source, which I always get excited because I can see the tool, I can use it, I can look at the code, and then when I have my own company requirements, I can start from what they wrote and customize it to my company or regulation needs. So it's all about Mule being a full stack microservice management utility. You start with your components, and it builds pipelines for you. It builds your CloudFormation templates. It deploys the services, leveraging what CloudFormation brings to the table, which means you can roll back things, et cetera. We manage the state dependencies, and it can manage the environments. And it uses many AWS native services. So you can get Mule, the URL stated there, getmule.io. I would like to demo what Mule looks like. And the magic here happens.
Just hit 2.
Just hit 2, right there.
Oh, wait, here.
Here? Yep. There we go. How many engineers does it take to? All right. So I'm using Chuck's machine, and Chuck has already set up Mule, downloaded it, initialized the project, changed the build spec to actually do the build and specify some environments. So what exactly has he done so far? I can call Mule and tell it to show the services that I have in place. So I'll scroll this up a little bit here, and you'll see that once Mule, again, the only thing that I changed after the initialization was by build specs. Mule took care of creating pipelines, creating stacks, and doing so in all the environments or stages that we configured. And you can see kind of like an event status of, I went through the build stage, I went through the acceptance stage, and then I went to the production stage. What deployments have I had, in what environment, and of course, because it's automated, it happens relatively quickly. Now, let's take a look at one environment. Mule, env, show, acceptance. There you go. So our environment is an acceptance environment. Provider is ECS. The cluster stack name and stack here is a CloudFormation stack. And the last event status is create complete. VPC stack, because we broke the infrastructure, is also create complete. And everything looks quite kosher. So let me switch now to the browser-based interface, because I want to show you after this run what happens from a code pipeline perspective. Actually, I shouldn't log you out because it is on your code pipeline, isn't it?
Yep, that's right.
So because of me being too happy with the clicks and everything, you're going to get to see Chuck log in again.
All right, no one copy my password. Another thing that might be useful that we can show you after we look in here too is Mule is a very opinionated tool, which is kind of one of the things that makes it interesting. The configuration that you have to do everything that we just did is very small. We'll look at that as well, I guess.
Yes. So I'm going to show you here in code pipeline. This is the banana service. This is all generated by Mule. You never have to log into the console, and it generates the stages. Source gives you events. It can tie to, for you to link to the details for all of them. Acceptance and production. All this generated on your behalf by the Mule tool. Your CloudFormation is going to have your Mule stacks. That's the stacks for the VPC, load balancer, environment, and for the service itself. And you can see that it creates resources like ECS task definitions as well. Now, let's show at least one of the files. The build spec is right there. Ooh. Cool. Very simplistic. In the build phase, I'm going to call Gradle build. And I should have also the configuration file. Here I can define, I need 2 environments, acceptance and production. I'm going to give it a path. I'm going to use as a source GitHub, and the repo in GitHub, and my build images will require Java OpenADK. So very convenient, and once again, because this tool is open source, even if you end up not using all the components, look at the code, because you probably will have some really interesting ideas as to how to automate other ECS and Docker processes.
Cool.
All right.
Excellent.
Back to the slides. So we've seen EC2, traditional compute. We've seen Docker, container compute, serverless. Pipelines apply to serverless as well. The examples that we'll talk about today will use one of the tools that we vend, which is a framework called Serverless Application Model that I think both mentioned before. What it does is, from a CloudFormation perspective, if you create a Lambda manually, you have to use AWS : Lambda : function. You have to make sure that you have your security and execution rules and permissions set. In many cases, you have to also build your API gateway endpoints and other components and dependencies like a DynamoDB database if you're using that. With some of these serverless resource types, and you use AWS serverless function, a lot of these things are generated for you. And it really, beyond that, it supports anything that CloudFormation supports. It's been open sourced. The translator has been recently open sourced. But SAM is mature to the sense that it's been available for a couple of years. And another thing that it has is a tool called SAM Local, where you can do a lot of your development in SAM while being disconnected from the network. And it has simulators for things like DynamoDB.
One thing maybe just to add, the linter that we were talking about earlier integrates with that SAM translator. So you can actually use the same linter to validate a SAM template that you would a regular CloudFormation template.
So for you CloudFormation folks, this is what a SAM template looks like. Very much like a CloudFormation template. Biggest difference, you see the transform definition there, which is where it says AWS Serverless 2016-1031 on the second line. And then with this abbreviated resource, that's of type serverless function, you define the handler, the runtime, and a policy right in line, and it generates a whole bunch of these things for you. So now let's look at the pipeline if you were using SAM for CI/CD. The beginning kind of like stays the same. And in code build, you'll have your code artifacts, your change sets that it generates, and then once those change sets are generated, you can make things happen, like, for example, require manual approvals or do automatic approvals. As you write other tests, especially for your API endpoints, you can do API testing with tools like Postman. If you use SAM and the AWS Serverless API resource type, SAM can automatically trigger a new API gateway deployment as part of your regular CloudFormation deployment. So you yourself don't have to manually add any extra custom deployment logic to it. CFN build is also integrated with SAM, and it will generate a template instead of a native CFN template if you add an NT file called produce SAM merge file in the package root directory. So to summarize, don't think that your application and the application architecture is such that it cannot benefit from a pipeline. We talked about very traditional, probably people would consider web-orientated applications. But even in EC2, if your application is more analytical versus transactional and you're deploying data lakes, you can set up pipelines for this as well. In the same way that, that you can do unit testing for code, you can do database unit testing as well. Same applies to the other application architectures that we discussed. Key takeaways. The benefit of treating infrastructure and definitions as code is, number one, it's really solid documentation, because the documentation for perhaps an auditor or something, it's right there, or code that you're executing. Number two, you can take the same type of tools that people use for code, testing, linting like we mentioned before, and apply those same benefits to that code. The automation makes it repeatable. When you're using a tool like CloudFormation, not only is it repeatable, it is also reversible. So there's so many benefits to them. We're at a point that if you want to live in the world that you have to compete and release a lot of features quickly in a stable, predictable way, I don't see of any other way of doing that without really buying into DevOps CI/CD for all your applications in your portfolio. Versioning. We were talking before about one of the practices being when you do a commit, put a meaningful message on the commit. Sometimes something breaks and it's not obvious what broke. It can lead you quickly to the solution if you look at your commits and said, this is where I changed my routing table. And if the error that I see is a routing table error, I can completely drill down to the previous 2 versions of that file and why did the change actually broke. And in many cases, you can just say, well, let me restore the previous version. So that's where version control becomes important, and having good discipline with Git commits is important as well. Now, I met a lot of customers, because I do a lot of these DevOps presentations, and many CloudFormation developers come from more of an operational background. So it does make sense that they're not experts on things like version control and Git and some of these tools. But if you're open to learning that, you'll get significant benefit from having this automation in place. Testing and testing everything. You want to test everything from the very beginning of your code all the way to when code lands in production. And why not start testing while you're authoring the code? This is one of the reasons why we show you the editor with the CloudFormation linter in particular. You can avoid errors by the time you save the file and not have to go through this process of going to the console, try to upload a template, find out there's an error, going back to your editor. It just dries up a lot of minutes. In many, many, many cases, I think there's examples of if you're hitting API throttling limits. In many, many cases other than that, you can avoid any validation errors by using a linter, not only in your editor, but also by using the linter in the headless mode like he was doing on pipelines. Also, while we're talking about testing, and I'm sure many of you have read the CI/CD book by Jess Humble, and it describes kind of like a traditional test. Once again, as new components come along, new ways of testing those components also are emerging. So as these pipelines are in place, expect them to change, expect them to grow. Group resources by lifecycle. This is, if for any other reason other than to reduce your blast radius and risk, do it also because you make each operation a lot faster to execute and a lot easier to troubleshoot and test. And then deploy it all via pipelines. One of the things that I've heard a handful of people do is to say, well, we have a pipeline for production stuff. But for development, we just kind of like throw things in there and QA does other things. You're only going to get the maximum benefit of this if you're doing pipelines from the very beginning, including for dev, for QA, for preview, for stage, et cetera. And then as you're doing that, ensure that you keep the configuration details of the application outside. One thing that you mentioned about keeping parameters outside, CloudFormation now supports keeping parameters in parameter store, keeping secrets in secrets manager. Those things also take advantage of versioning as well.
Yeah, we can't stress enough about starting early. The whole advantage, right, of infrastructure as code is providing consistency across environments, not having that surprise in production because someone made a manual change. So by putting this automation in place, you're enforcing that. You're making sure that the lower environments are an accurate representation of production, not just for the application code, but for your configuration management and for the infrastructure itself, right? What is the impact of having encryption on? Maybe you don't want encryption on everywhere, but having encryption on in lower environments is certainly going to tell you a lot more about the latency of your application, so you don't have that surprise when you move to production and move to encryption. So.
Now, we've covered a lot of stuff about CI/CD pipelines, different architectures, techniques, tools, testing, and versioning. And many of you might say, well, how the heck do I get started? Do these things kind of like come pre-built? There's some examples, and there's tools that, like Mule, that actually help along. But it's perfectly okay to go ahead and get started with a minimal pipeline that it's connected to Git or version control and runs a job and copies something, and then you build from there. When that pipeline matures, then you start putting in production. I can almost always assure you that some of these very fancy pipelines that you've seen did not start day one with all those components. They kind of like evolved and everything. I remember one of the areas that we spent in pipelines before when I was in another job was picking out the slowest part of the pipeline, which invariably was going through the test suite, and come up with different ways to speed up the test suite and everything. Once you speed that up, something else becomes the slowest thing, and you try to automate it. But you continue to iterate, and over time, you'll have a fairly stable pipeline that, once again, gives you the innovation and gives you the ability to tell people, we can release quickly with discipline in an auditable, repeatable way. Okay. With that, there's some links to some of the tools that we mentioned, the linter TCFN lint, the two tools by Stelligent, CFN NAG and Mule. TaskCat, if you remember, we talked about that being developed by the AWS Quick Starts team. And again, take a look at those quick starts, even if you don't need to deploy something like Apache Zeppelin or SAP, which are some of the quick starts, because there's a lot of really neat things in that code that you can reuse in your code and get some good ideas. We do a session here about hardening accounts with CloudFormation, and we use Quick Start that we collaborated with the Quick Starts team and Accenture and an organization called CIS, the Center for Internet Security. You can harden accounts with CloudFormation, creating config rules and Lambda, and it literally takes 20 minutes to set it up. So there's really no good reason not to take advantage of those tools. We also mentioned the SAM tool. You have CLI, and again, you have the ability to test locally with that as well. Thank you so much for attending.